World chemistry to a type of reaction called equilibrium. Equilibrium is a type of reaction where a forward and inverse reaction reach a point of dynamic balance. Now, the word dynamic means changeable. That value can be changed where it reaches. So, how do we know where that balance point takes place? We take what's called the equilibrium product constant. We can take a reaction, and the way we show it's a reversible reaction is we have a double-headed arrow, okay? And we only use concentrations. Whenever you use little brackets, that means concentrations. We take the concentrations of the products raised to their exponents, so the coefficients here become exponents, divide by the reactants by their exponents, okay? So it's products raised to their power over reactants over their power, and only concentrations of gases and solutions. Solids and liquids don't have concentrations because they're pure. They're not part of something out of something. All right? So if our KEQ is less than 1, what does that mean? That means we have more reactants at the end of the day. We have more reactants and less products. If the KEQ is greater than 1, so we call product favoring reaction, we have more products and less reactants. All right? So let's look at a problem. For the equilibrium reaction constant for the Haber reaction, if at equilibrium the concentration of nitrogen is 0.2000 molar, concentration of hydrogen is 0.600 molar, and the equivalent concentration is 0.003544 molar. Now, Haber reaction, what's that? Well, the Haber reaction is this reaction. It's the formation of ammonia. And the reason why it's called the Haber reaction, because it's the first ammonia equilibrium reaction discovered by a German scientist named Haber. Balance it up. It was the first reaction studied. Balance it up. We're going to put a 2 there. And we're going to find out the value called KEQ again. We do that by taking the concentration of our product, and the coefficient there is 2, so it's going to be to the second power. Divide by the concentration of the reactants, which are nitrogen and hydrogen, raised to their exponents. And then we put the values in. We see the problem. The concentration of ammonia is 0.003544 molar. Concentration of nitrogen is 0.200 molar. And the concentration of hydrogen is 0.600 molar. Multiply through and we get 0.002907 or 2.907 times 10 to the fourth. You'll notice the KEQ does not have any units. KEQ never has units. It's just a number. That's my answer. All right, here's the second problem we'll do in class. For the reaction of hydrogen plus chlorine to give me hydrochloric acid, find the concentration of HCl. If the KEQ is 4.667 times 10 minus fifth, concentration of the reactants at equilibrium is 0.2566 molar. And we'll look at this one in class. Determine the reaction is at equilibrium for its synthesis of hydrogen fluoride. The concentration of hydrogen and fluorine is 0.00225 molar, and the concentration of hydrogen chlorine is 0.0175 molar, and the KQ is 0.345. All right, 2 problems. Copy this one down and this one down. And just so you know, that is the reaction there for that problem. All right, that's it. We're done. Take care. Be good. Bye.